thank you for joining us today during these workshops. We are organizing this meetup in collaboration with the ESSAI Junior Enterprise. ESSAI, it's the French abbreviation of the Higher School of Statistics and Data Analysis. It's an engineering school in Tunis. And this association is operating on the model of a professional consultancy firm. And so it aims particularly to address the issues of a data science field. So you look really forward to doing outstanding work together. And I'm really honored to have today between us Riva Quiroga, which is a PhD candidate in linguistics, and she's also the organizer of Arle di Santiago. And I'm really happy to have you here today between us, Riva. Also, we are really honored to have Dr. Mohamed Ihaddaden, who is a PhD in economics, and he has also Masters of Science in Statistics and Applied Economics. He's also an art developer and RStudio Certified Instructor. So during our meetup today, the workshop will be mainly about web scraping. Riva will start presenting her work, then we'll have a time break about 5 minutes, and then Dr. Mohamed, he will introduce to us his R package ledger. Thank you all again for joining us, and I think it's time to start. The floor is yours, Riva.
Thank you very much. Thank you for the invitation. So I will be in charge of the first part, where we're going to run a workshop about how to do web scraping using Arvest. That's the web scraping package that's part of the Tidyverse. First, I'm going to introduce myself. Well, my name is Riva Quiroga. I'm currently, I live in Valparaiso, Chile. That's over here. We're in the middle of the summer, so it's very hot right now. I'm a PhD student in linguistics, where I'm using R to explore how political speeches change over time. I'm also part of Our Ladies. I organize the groups in Santiago and in Valparaiso. And I'm part of the community in Latin America. For example, we have this group that's, we translated the R for Data Science book to Spanish, so more people here can learn about how to do data science with R. And I also organize the Latin R conference. That's the conference about all the things R in Latin America. I also work as an editor in Programming Historian. This is a platform where we publish peer-reviewed tutorials to help people from the humanities to learn digital tools, techniques, programming languages, and workflows. And it's multilingual. We have it in English, in Spanish, in French, and soon it's going to be in Portuguese. Next week is RStudio Global, the RStudio conference. And I will be there giving a talk. And I just saw that Pame Pairo from Argentina is also here. She's also going to be giving a talk. So if you want to join us next week, that will be great. So we're going to talk about doing web scraping using R. Specifically, we're going to use the Arvest package. As I said before, it's the package that's inside the Tidyverse. And I'm going to run through 2 examples. The first one is about how to scrape many pages. So sometimes all the information you want is in different pages of a same website. So we're going to see how we can do that. And the second example is going to be how we can scrape many tables from a website. So sometimes there are many tables and you want to have them all in one big table with all the data you're interested in. So that's the second example we're going to run. We're going to join all the tables, and depending on how many times we have, we're going to start cleaning, because one of the things that happen with web scraping is that sometimes it's easy to get the data, but the data is very messy, so you have to clean it. So I think I have an hour and a half. And so depending on how much time, it's how much cleaning we're going to be able to do to the tables. Anyway, if we are not able to clean it till the end, I will leave the code for doing that afterwards. So one thing that we need to ask before when we're doing web scraping is not if it could be done, because finally you can web scrape almost anything if you work enough time in the task. But we need to ask ourselves if it should be done, because there are many websites that doesn't allow you to scrape their content. So before doing web scraping, you need to check if you are allowed to do to take the information from the website. So you're doing web scraping in an ethical way. So we're going to see what things we need to check in a web page to see if we're able to do the task. So this is a workshop where I will be doing live coding. So all the code, I'm going to be writing all the code. I don't have a pre-written script. I'm going to start typing from the beginning. So I will share with you a link where all the code that I will be writing is going to appear. So you can follow me on the screen, or you can also check this, this link. So I'm going to show you how it looks. Just give me a second. So if you open that link, you're going to see something like that. That's the beginning of my script. So I'm going to put this, let me open my script. Just give me 1 second to show you. So for example, if I write here something else, for example, the packages we are going to use, and I save my script. If you go to the link I gave you, if you refresh the page, now you see here the line I just wrote. So one important thing is to remind me to save my script. So that's the only way everything is here is going to be updated. And this is like so here you can copy paste in case something you missed something. You can copy paste the code, and after the session, if you want, you can download it to have a copy of the script. So everything I'm going to I write on my computer is going to be updated here, so you can see everything I'm going to do. So as I said, it's going to be live coding, and this is the last slide. Everything is going to be done in RStudio. So as I said to Paul that asked about the slides, there's no real content on the slides. We're going to work on RStudio directly. So the script is like the content of the workshop, and you can have it. Now you have the link to the script. So let's start. As I said, we're going to run a first example that is about scraping many pages from one site. And we're going to scrape the page of our open site. They have a blog. So they have many entries on the blog. I'm going to, for example, I'm going to put here next. And if you see, their blog has 61 pages. So imagine that we want to know what all the posts they have been writing in the past few years are about. So we want to scrape all the titles of the blogs. So we not only need to scrape one page, but we need to scrape the 61 of them. So that's our first example. But the first thing we need to do is to see if we are allowed to scrape a website. So I'm going to show you with Amazon. So how do I know if I am able to scrape a website? So one thing I have to do is go and see if the page has something like condition of use or term of use, and check that part of the page. Usually this is something very big. like a lot of text. So how to find if I'm able to do this or not? One thing you can do is search for words like, for example, data, robots, or other words, mining, for example. Those are words that you can, or extract. Those are words that you can search in the page to see if you're allowed to do that kind of stuff. So I'm going to find in this page. And I'm going to search, for example, for the word robots. Okay, so here's something. So here in the part of licenses and access, it says that the license does not include, okay, it's a resale, commercial use, and then it says any downloading, copying, any use of data mining, robots, or similar data gathering and extraction tools. So here Amazon is saying to us that they do not allow us scraping their website. So as I said before, this doesn't mean that you can't do it in terms of being able to do it. Actually, you can scrape the site if you want, but you're not doing it in an ethical way in the sense that they're asking you not to do it. So that's something you need to check before doing web scraping, if you're allowed to do that kind of extraction. In the case of our OpenSci, they publish their content with a CC BY license. So this is a page that we can actually extract the content, so there's no problem in this case. So as I said before, we're going to running some examples. I'm going to put the packages you need to have installed in case you want to follow the examples. I just put them on the chat. So we're going to be installing the tidyverse. There's a good question. If RS can scrap tweets, for scrapping tweets, it's easier to use the RTweet package. I'm going to put the name on the chat. Actually, that's a package developed by our OpenSci. So in that case, it's easier to use RTweet to scrape Twitter. So it actually can be done, but the thing is, it's only going to scrape the tweets that you're actually seeing on the page. So it's easier to use RTweet because you can scrape, for example, a hashtag or tweets from a specific account and stuff like that. So I'm going to RStudio. And what I'm going to do here is that I'm going to start a new project. I'm going to create a new directory, new project. And I'm going to browse in my computer where I want the project to live. I have an Our Ladies folder, so I'm going to put it there. And the name is going to be Web Scraping Workshop. So now RStudio is relaunching, and I'm going to move my the script that with the link to Dropbox that I sent to you. So I'll be working in this script. Okay, so the packages we're going to use are, let me write them here. I'm going to activate them. So the first one is Harvest. That's the package that we're going to use. As I said, Harvest is part of the tidyverse, but it's not loaded when you use library tidyverse. So you have to attach it individually. So we're going to use the tidyverse also because we need functions from the dplyr package, from string R, and from other, for example, for tidyr, we're also going to use. So I'm going to touch that package too. We're going to use a package that's called robots.txt because it has a function that also helps us to know if we are allowed to scrape a website. So we're going to check that function. We're going to use the janitor package for the second example because we Janitor has many functions to clean data. So there's a very good function for cleaning the names of variables. So we're going to use that one. And the fifth package is tidy text. In case we have time, we're going to see what are the more frequent words in the R blog posts. Okay, so those are the packages that we're going to use. So when we're doing web scraping, the bit.ly link is for the, there's a question in the chat about that. That's where this script is, so you can follow it. Okay, let's go back to what we're going to scrape. So this is the page. So we know here we have the post on the blog from our open site. So when we're doing web scraping, basically what we're doing is bringing all the information in the HTML page and look for the information in the tags from the HTML that we want. So I'm going to use here an option from my browser that allow me to see like the source code of this page. So this is the page, this page. This is the source code. So what we're going to do is that we're going to import everything here. And then what we do is try to find in all these tags, which one has the title of the blog post, because that is what we want. There are many ways to check them, but we're going to see a couple of them. So when we're scraping a web page, we need the URL, and then we need to see in which part of the HTML code is the part of the page that we want. So there are many ways of doing this. One is using some options of your browser. For example, now I am on Firefox, and there's an option that you have like tools for developers. And there there's an option that's called the inspector or activate the tools. In Windows and on Linux is Control-Shift-I. And this will show you all the HTML of the page. So on the top left part of this console here, you can see that there's like a small square with a cursor here. So if you click that and you move in the page, it starts like highlighting some part of the page. So for example, if I go to the title, that's the part that I want, I can see that in blue, in this case, says period post dash title. So that's the tag where the information I want is. So one way is doing this way with the tools that your browser has. And there's another way that it's using Google Chrome. And Google Chrome has a very interesting tool that's called Selector Gadget. It's an extension that you can put to your Chrome browser. I'm going to show you the same example now in Chrome. So I'm going to Chrome now. Let me move it to this screen. I'm going to search the same. And it's the same shortcut. So it's Control or Command in case you're in Mac, Shift-I. And in this case, in Chrome, you're going to see this panel on your right. So if you click the top left part, it says select an element in the page to inspect it. You can also directly put Control-Shift-C, and then you can go to the part of the page that you want. So this one is the one we want. So this is the second important thing you need to know to scrape a web page. So the URL and the tag, the HTML tag of the part of the page where the information you want is. So in this case, is the information that is in the top right of this little square. I can't point it because my cursor will move and I stop seeing that part. But I'm going to put it on the tag. So we find out that the part that we want is in post title. So as I said, there's this tool that's called Selector Gadget. I put you the link in the chat in case you want to install it. And it's very interesting because you can, with this extension, you can point the part you want and it will give you the tag. So for example, here in my browser is this little magnifying glass here. So if I click it, I can go through the different parts of a page and click the part I want. So something that is really useful about Selector Gadget, if, for example, I just click the part I want, so now I know that post title is the tag that I'm interested in because appears down here. And it shows me all the other parts of the page where the same tag is used. So I can check that, for example, in this case, it's highlighting the 5 titles of the post. So this is very useful because you can check that tag extract all the information you want, but no more and no less. Okay, so now we have the 2 informations we need. We have the URL of the page. In this case, we're going to start with page 1. Here are the links we want. I'm going to check again with Selector Gadget. So we have post titles, and the only thing that is highlighted in the page are the titles of the post we want to scrape. So we have the link. I'm going to put the link on the chat also. And we have the HTML page. So now we have all the information that is needed to do the web scraping. So I'm going back to RStudio. There's another way to check if you can scrape a page, but this one is not every time you can use this one because sometimes the page doesn't have the information on the robot.txt file. So I'm going to check if we can scrape the page with robots.txt. So let's check if we can scrape the page. So there's a function from this package called robots.txt that's called get robots.txt, and you can put here the URL of the page you want to scrape. So I'm going to show you first what happened if you put something like Amazon here that doesn't want to be scraped. So if you see here, it says, you can see that it says that disallow, disallow, disallow. It's like saying that they don't want to be scraped. If we use the URL of the OpenSite blog, you can see that here it says allowed. So they're saying that there's no specific tool that is disallowed to use to scrape the web page. So this is another way to check if you are allowed to web scrape a page. So now we know that we can actually scrape this page. So we're going to start doing the scraping. So the first thing we need to do is get all the HTML of the page to R. So get the HTML. So I'm going to create an object. I'm going to, when you want to scrape, for example, many pages from a website, it's useful to first check if you can do it well with one page. And if it works, then you can scale and do it with the other pages. So I'm going to first scrape the page number 1 of our OpenSite blog. So I'm going to create an object that's called HTML1. And the function we need here is the read HTML function and the URL of the page that you want to scrape. So I'm going to put here Yeah, there's a good question in the chat. It says about Amazon, you said that we can scrape it, but ethically speaking, we can't. But using robot.txt, how it can know that we can scrape a website? Because it's going to say that you're disallowed. So here they're saying that they're disallowing tools for doing web scraping. And in the case of our OpenSite blog, it said that they allow them. One thing with this way of checking the information is that robot.txt is it's a file that everyone with a website should have, because in that file is where you put the conditions to use the technical conditions in terms of which things are allowed or not. But not everyone use the robot.txt to put that information in. So you should always take first the terms or condition of use. And then if nothing says there, you can check the robot.txt file. And if it says nothing, then they're not explicitly saying you that you can do it, that you can do the web scraping. So now we have this HTML1 object here, and we use a read HTML function with the URL we want to check. And what this object has is basically all the HTML structure of the page. So it have like the head, the body of the page, and it's all the content here. And it's organized with the tags of the HTML. So now that we have all the HTML here, what we want to do is saying to R that only keeps the one that is inside the tag that we want, that is this post title tag. So what we're going to do now is extracting the information from that tag. So I'm going to create another object that's called title1. That's going to take all the HTML information in HTML1. And then we're going to use a function that's called HTML nodes. Here it's important to choose the one in plural, because if you choose HTML node, it's only going to extract the information from the first one. So you need to choose HTML nodes. And inside HTML nodes, you said which tag do you want to scrape. So in this case, we want post title. Yes, Sylvia is saying that it's very pipe friendly. Yes, you can. Actually, we're going to create then a function to scale the process, and we're going to use pipes because I think it's very easy to write the code this way, because you can see all the steps there that you're going to take. So we take all the HTML code here, then we're going to extract with HTML nodes everything that is on the post title tag. And then we need to tell R in which format we want this. So in this case, we're only extracting text, so we can use the HTML text. In the next example, we're going to scrape tables. So for example, here we want to put HTML tables because we want to keep the table structure. In this case, we're only going to scrape text. So we don't need to do anything else. So I'm going to run this code. And if you see here, I'm going to print it on the console. Title1 now has our object where we extract the text of the node's post title, has the 5 titles that were on the first page of the blog from our open site. So I'm just going back to the blog to check if we scrape it correctly. So our open site code of conduct, and the last one is donate to our open site this given season. And we have here the 5 titles. So because we don't have enough time now, we're going to just do it with the titles, but then you can check if you want the authors, you can check in which tag the author are. And you can also, for example, you can then scrape a link where of each post, and then you can scrape all the content of the post, so you can scale this analysis in different ways you want. But once you have the URL and once you have the tag that you want, this is like the process. So for scraping the titles of one page, you just need these lines of code. So if we want to scrape 61 pages, the easiest way is that we create a small function that have all this code, and then we can iterate through the 61 pages. So what we're going to do now is create a small function to scrape the titles of our OpenSci blog. So I'm going to name this function getTitles. And I'm going back to the blog to show you how the URL are. So I'm going to page 2. Let me get out of Selector Gadget here. So if you see our URL have this structure, we have like opensci.org /blog/page/ the number of the page. So what we can do is create a function where we give the number of the page, and the function brings us back all the titles inside that page. This is something important to take into account when scraping a website with multiple pages, is that for doing it with RVest in this way, you need to have, for example, if the website has 61 pages, you need that all the pages have a different number. So there are some web pages where if you change the number of the page, the URL doesn't change. In those cases, you can use RVest. There are other packages that can you use, for example, rSelenium. I'm going to put the name in the chat. So there's the question about that it says, for example, if we did not have the data on 61 pages, we just have all the data on one page with a load more button instead of text. In those cases, you can use RVest. You need to use something like rSelenium because you have to simulate the clicking in the load more button. So RVest is only useful in these scenarios where you have a URL that is changing. But if you have like a load more button, you need to use something like rSelenium because you need to create the process of clicking the load button to show more things. So in those cases, that's the other approach that you need to follow. Okay, so in this case, to scrape the 61 pages, we need to go through this URL, but changing the number at the end. So what we're going to do is that our function take the page number, and it gives us all the titles in that page. So the first argument the only argument of our function is going to be page number. So one important thing when doing web scraping also is that every time you go to a web page and do a request, it's useful to stop for a couple of seconds between each request, because if you do too much requests to a web page, they can block you. Bob Rudis has a very interesting blog post about ethical web scraping with R. I'm going to share with you the link. He suggests to putting 5 seconds between each request. For example, in this case, between each time it goes to a different page, we put 5 seconds. So the function stop 5 seconds and then request information from the other page. In this case, we're going only to put 2 because we have like we don't have all the time of the world, so it's going to take too long, but he suggests putting always 5 seconds. So there's a function that's called sysleep, system sleep. I'm going to put 2. So every time these functions function go to a web page, it's going to bring the information and stop for 2 seconds, and then it's going to make the next request. So for our function, I'm going to use almost the same code here. I'm going to put it in one chunk of code. But the first thing we need to create is an object with the link of the page. And in this case, we want to use like the first part of the page without the number, because that's the part of the URL that's common to all the pages. So the first thing our function is going to do is to create the URL of the page we're going to scrape. So in this case, we're going to create this URL pasting the ROpenSci first part of the URL, and then we want that after that it puts the page number. So if we put here, for example, 51, it's going to create the URL that said /page/51. So that's the first part of the first action inside our function. And then we're going to use the same functions we used here. We're going to read HTML, the link, then the HTML notes. I actually can copy and paste this. I'm going to put some spaces here so we can see that we're doing 3 things inside our function. We wait 2 seconds, we create the link, and then we scrape the link. So now I'm going to run this code so I can save my function. This is a small function, so I can select everything and run it. But if you have a longer function, if you click here on the first line, you can see it have a small triangle. If you click it, it's going to collapse all your function in one line, so it's easier to run it. Now I'm going to put it back. Okay, so I'm going to test my function to see if actually doing what I want. So I'm going to try my get titles function with page 61. Okay, it showed me only one title, so I'm going to page 61. And that's okay, page 61 has only one post, so that's okay. So my function, it's working. So because we want all the pages, what we can do here is using one of the map functions or one of the apply functions, if you prefer. So now we're going to check if we can iterate using this function. So it's best to try first with 2 or 3 pages, because you try to iterate with the 61 and then it doesn't work. You're going to wait for a very long time. So I'm going to use the map function. So I'm going to say to the map function, go with the number 2 to 4 in the get titles function. So what this function is going to do is that it's going to add as an argument for get titles the numbers 2 to 4. So it's going to do like get titles 2, get titles 3, get titles 4. So I'm going to run this. Because it waits 2 seconds between each request, it like takes a couple of seconds. So now we have 15 blog post name. That's okay, because that's what we want. We scrape 3 pages and there are 5 titles per page. I'm just going to check. For example, I'm going to page 3. It starts with ROpenSci Dev Guide 0.5 point and here, this one. So it's fine. If you see the map function by default show us a list. So if we want just the titles, we can use the unlist function. So now we're going to wait. And now we have the 15 titles as 15 strings. Okay, so we have the function and we know we can iterate using the function. So now we're going to get the 61 titles that we want. Because it takes a long time, I'm going to do it like in 2 steps. So I'm going to scrape from, we already have the title 1. So I'm going to scrape for title 2 to title 30, and then from 31 to 61. You can do it all at once if you want, but if you're not sure about your computer capabilities, you can always do it in like small chunks and then put everything together afterwards. So now I'm going to get the rest of the titles. So I'm going to create an object that's called getTitle to 30. And I'm going to map from 2 to 30 with the getTitles function, and then a list. So I'm going to run that. It's going to take, I think, 1 or 2 minutes, and then I'm going to do with the rest. Okay, I just saved, so the Dropbox, now you should see everything there. So there's a question, what if we have an error? For example, a specific page did not load. That's a very good question. What you can do when you map is that you can use a specific, from the per family of function, there's one function that's called safely. Let me look for it. I'm going to so the safely function, it's a way of using all the functions from the per family that has a very good, it's very interesting because when you, if for example, there's an error in one of these pages, I'm going to get an error on my code and it's going to stop. But the one thing that has safety that's very useful is that it's going to run all the code and it's going to say you in which part the code failed. So you can know, for example, oh, page, I don't know, 55 failed. So you can remove that from your code. So let me go back to, reference. And the function is called safely. I'm going to put the link here. So also in the R for Data Science book, in the sections about iteration, there's an example of how to use the safely function. So my code is still running. I put only 2 seconds. If we follow like the Bob Rudy's guidelines about using 5, it will take a lot more, but because we're here in a workshop, we're putting less seconds, but if you do it in some other case, the recommendation is to do it 5 seconds. So that way you don't get blocked because you're doing too much requests to the site. So, okay, now I have like my 2 new objects. So I have 145 titles on title 230 and the rest in the other object. So now I'm going to put them all together to have everyone in just one object. So I'm going to create an object that's called ROpenSci titles. And I'm going to put them all together. So we have title 1, title 230, and title 3161. So now we have all the titles here. So if we look to our object, so now we can do anything we want with this object. for example, I think we're okay with the time. I'm going to check which are the most used words in these titles. So let's see. The most frequent words in our OpenSci titles. So I have this object that's our OpenSci titles, that's a character string. So to use the tidy text package to see what are the most frequent words, I need to them to be a data frame. I'm going to use the table function because I like the way tables are printed in the console. But it's a data frame. You can use the data frame function if you want. So I'm going to create a table that has one column that's called title. And inside the column, I'm going to put the R OpenSci, everything that's inside my R OpenSci object. So now I have a table with one column and 301 lines. So now I have each title in a row. So the next thing I'm going to do, I'm going to use the nest tokens from the tidyr package. So sorry, from the tidytext package. Nest tokens. Well, this function split the text in tokens. By default, it assumes that a token is a word, but you can also do this with bigrams or trigrams if you want. So the output, it's I need to set in what column I want the words to be. I'm going to name that column word. Then what the input is in this case, the information I want to nest in tokens is on the title column. So I'm going to put here title. And there are other options. For example, if you want, this function is going to turn everything in a small case. It's going to remove punctuation by default. But by default, it doesn't remove numbers. So if you want to remove numbers, for example, years, or it in this case can be useful because there are many blog posts that are called like version 1.5 for package X just released. So if you want to remove all the numbers, you can put here strip numbers, strip numeric equal true. So this, what this does is that it puts all our the information we had in the titles in one column that's called word. So now we have like every word of all the titles like in one column. But what we're going to do is to count which are the more frequent. So we're going to use the count function. And we're going to count everything in column word. And we're going to say that we want to sort them. So the most frequent ones are in the top of our data frame. So we have here the OpenSci in with an R data A24. So what we have here is a lot of function words, that is functions that have a grammatical use. So we need to do what Akil says on the chat. We need to remove the stop words. Stop words is a term that it's all the words that you want to remove from an analysis. Usually they include the function words, grammatical words like, for example, articles, in English, conjunctions, for example, and stuff like that. So we're going to remove them with the anti-join function. There's a stop word data set for inside tidy text. So you don't need to have your own stop words list, but you can create one if you want. So now we can remove, and now we know that the most frequent words is our open site, then data, package, community, software, review, research, code, introducing. If you, for example, don't want to consider our open site because it's our open site blog, that's kind of an obvious word that you're going to find. You can remove it, for example, with the filter function. And we want to remove from word. And we use the equal sign with an exclamation mark before to say that not that one, our open site. So now we remove that one. So data, package, community, software, review, research, code, introducing project. So if you want, then you can explore the most frequent bigrams, or you can create, for example, a plot showing these most frequent words. So that was our first example. What we did here was scraping a website that has information in many pages. So what we do is that we first try with one page to see if it works. What code we need to extract the information from that one page. In this case, it was easy because we want just the post title, but you can make this more complex, that you can extract the authors, you can extract the date, you can extract then the URL of each post, and then extract the information inside the post. There are many things you can do. Having a little bit of knowledge about HTML is always useful because it's easier to find the HTML tag you want if you have a little of knowledge about HTML. So we tried one time, it worked. So then we create a function with that code, so we can iterate then in all the pages that were interesting. And after that, we create an object where we store all the titles, and then just like a research question, we explore which were the most frequent words in our open site titles. So our second example is about scraping tables. Usually we found tables with interesting data sets on web page, but they're not downloadable because they're on the HTML. Then there's not a CSV file or Excel file that we can download. So one way we can do is scraping those tables with RBest. So the example we're going to go through is about from Wikipedia, because Wikipedia has a lot of data set and a lot of tables with interesting information. So here's the list of best-selling music artists from in different decades and in different range of income. So here we have, for example, the ones that with 250 million or more records, and we have a table. And then we have 2 million to 249, and we have another table, and then another one, and another one, and another one. So we have, I think there are like 6 or 7 tables that it will be very useful if we want to make any analysis, we need to have all these tables in one. So what we need to do here is scrape all the tables, and then we're going to bind them together. So one interesting thing about Wikipedia is that they're it's very neat, their code. So they have like the tag for all tables in Wikipedia. It's called a wiki table. I'm going to the same page on Chrome. I'm going to use Selector Gadget in this case. And Selector Gadget, you can point the part of the page that you want, or you can search by the name. For example, here in the bottom part where is the search box, I'm going to put .wiki table. And you can see that all the tables in Wikipedia articles has this tag that's called wiki table. I'm going to put it on the top. And I'm also going to put the link that we're going to scrape. So I check with Selector Gadget at all the 6 tables I want. are highlighted. So these are the ones that we're going to scrape. So all of them have 7 columns: artist, country market, period active, release year, first started record, genre, total certified units, and claim sales. Wikipedia allows scraping the website, but it has very interesting messages. So I'm going to check for them. So I'm going to use the robot.txt function in the, first I'm going to use it in the Wikipedia page to show you what they say in that file. So they say, there are a lot of pages on this site, and there are some misbehaved spiders out there that go way too fast. If you're responsible, your access to the site may be blocked. So they basically saying that please don't go too fast. And that's the reason why we, for example, here, we put the sleep function to wait 2 seconds between each request. Here, Wikipedia is saying to please do that kind of adjustment, because if you go too fast and make many requests, they're going to block you from the site, and you won't be able, they're going to block your IP, so you won't be able to scrape more stuff from the page. So this is only, this like a polite manner of with scraping, and some pages warn you about not doing these kind of things. So we're going to do the same process. We're going to import the HTML. So get the HTML. So I'm going to create an object that's called charts HTML. And I'm going to use the read HTML function with our URL. I'm going to copy and paste it. So we now have the charts HTML function. This has all the HTML of the page. So what we need to do now is the same that we did before. We need to set to R which nodes we want, which tags we want, and what to extract from those tags. So what we're going to do is that we're going to create an object that's called artists tables. I'm going to check the charts HTML. Then I want the HTML nodes that's called .wikitable. And then in this case, we don't want the text in terms of the strings. We want the tables as such. So we want to keep the table structure. So what we say here is that we want HTML table. So in this case, it's not going to bring us just the strings with the information. It's going to give us all the table structure. So if I run this line of code, I'm going to check where artist tables has. So I'm going to click here in the object to see it with view. And we have here the 6 tables that we saw on the page. So we have artist, country market, period active, release year for the first table, the second one, the third one, fourth, fifth, and 6th. So now what we have is a list, and inside each list is one of the tables that were inside of the Wikipedia page that we saw. So we don't want to work with with lists. So we're going to convert those lists in one big data frame. And there's a function that's called a nest that can join all the data frames that are inside a list. So what we want to do here is that we join because they have the same names. You know, we have artists in all of them. We have, for example, country market. What this function is going to do is that it's going to join them in one big data frame. So I'm going to create an object that's called charts. I'm going to create a table first. let me show you first what happened if I just call the table function. If I call the table function, it's going to create a data frame that has inside each row one of the data frames. So it's almost similar to what we have before, but in this case, it's in the data frame structure. So we have one column that's called artist tables, and each row has one data frame inside. So all of them has 7 columns, because there were 7 variables on that columns, but they have different number of rows because some of them has more artists than the other ones. And then what we're going to do is that we're going to nest this data frame, and we had to set which column of this data, in which column of this data frame are the tables that we want to unnest. So we have to put calls artist tables. And what happened here is that now we have a table with 118 rows, like all the rows of all the tables join and all the columns. I'm going to save this in an object, and we're going to see that something strange happened. So now we have this in our charts object. So we had 7 columns, and now we have 8. I'm going to check with the names function, what are the names of our columns. So we have artist, we have country market, period active, release year of first started record, genre, total certified units, claim sales, then again release year of first started record. So what happened? I'm going to take a look to this here. So we have 2 release year of first started record, and that happened because we have one version that has a dash. I think you call the small line between words. This one has a dash, release year, and the other one doesn't. So because the name is not exactly the same, R puts them in different columns. So it seems that we have one table that has this version of the name here, and all the others has the name written differently. I'm going to check this in Wikipedia's page. Let me close Selector Gadget so we can see that the first column, release year, is written like this with a space here, and then they put a dash. So we need to solve that. So we have all the information we want in just one column. But first, I'm going to clean the names of these columns because they have spaces inside. So I have to call them with backticks. So I'm going to use the janitor package to do that. There's a question that says sometimes web pages have tables displayed after, say, selecting an option from a pop-down menu. Can we do such? Yeah, not using RVest, but RSelenium is the package that allows you to simulate all these actions that are done by a user, like creating a drop-down menu or creating a next button on a show more button. So in those cases, you can use Selenium. RSelenium is the wrapper of Selenium. And that package can solve you all those cases where there's an interaction from the user expected to show part of the data. So I'm going to put the name of the package again in case someone wants to see. No, I wrote it back. See, there it is. So you can explore that package to do that kind of in all those pages where interaction is expected. Okay, so before resolving the problem, we have that our data is split in 2 different columns because the names weren't written the same way. I want to fix the name of the columns because they have spaces. So we have them, if we want to call them in our code, we need to use backticks. So there's a function that I really love that's called clean names. that's from the janitor package that I'm going to rewrite my object, and I'm going to use the clean names function. And what it does is that by default, it turns everything in a snake case. So it's small caps, and I don't remember the name in English of this underscore, I think it is. So it put an underscore between words and everything in small case. There are other options if you check the help of clean names. If you prefer, for example, camel case or small camel case, there's an argument that's called case, where you can specify which format you want. If you want, for example, small camel or big camel or any other options. I like snake case a lot because I think it's easier to read. And I don't have to remember if I put a uppercase in any part of the name. So fortunately for us, there's a function that can help us solve this kind of problem when our data, for example, here we have data and there only NAs, and here we have NAs and then the data we want. The function is called, I'm not sure if I know how to pronounce this word in English. I'm going to put it in the chat. Coalesce, I think it's the name in English, but I'm not sure. So now we're going to fix our columns release year column. So what we're going to use the mutate function. So I'm going to try, then I'm going to save in my object. So I'm going to take my charts object. I'm going to use mutate. And I'm going to create a new function, a new column. Currently, this one is named release year of first charted record. I'm just going to put it release first charted, so it's shorter, sorry, first. And I'm going to use the coalesce function. Is from the dplyr package. And I'm going to say that I want to coalesce these two columns we have. So right now our columns are named release year of first charted records and release year of first charted record 2. When janitor found two columns are and have similar names, for example, here the only difference between release year, the first version and the second one, was the dash. Because janitor clean names turns every space and symbol into an underscore, these two are going to end name the same. So it add a 2 to the second one. So if we take a look here, we're going to see that we have release year of first charted record and then release year of first charted record 2. So what we're going to do is we're going to use the mutate function. We're going to create a new column that's called release first charted, where we're going to coalesce release year of first charted record and release year of first charted record 2. And this is going to create a new column here that will have everything we want. So by default, mutate is going to put the new column to the right of our data set, but I want the new column to be after period active, so it's in the same place where it was originally. So here I can add an argument to mutate that's called after. So I have to put period after. And I want this column to be after period active. So as you see now, our new column is here. And it has the information of release year that was here. Oh, sorry, in this column, the old one. And instead of NAs, now it has the information of the rest of the what were in the other column. There's a new it's after trick. I really love after the said Sylvia. There's after, there's before. There are many interesting things that make your mutate actions more easy. And I really love an experimental one that we're going to use. It's going to be very useful for this example in particular. That is the keep argument. That what do you want to do with the functions? Sorry, the columns you use in this call of mutate. For example, in this case, release years of first started record. This one and number 2, we don't want to keep them anymore because they're not useful for us. Our information now, it's all here in release year first started. So you can use the argument that's called .keep. And we want to keep everything that was unused. So then that means that all the columns that we didn't use in this mutate call are going to be kept, and all the columns that we used, that was these 2, are going to be loose. So if I run this, now I only have the 7 columns that I want. Release of first year now is complete with all the observations that we want. And we don't have anymore the 2 columns that were where the information was split between. So this is how I want my data to look, with 7 columns and all of them with all the observations, no NAs. So now that this worked, and on line 84, I'm going to rewrite my object. So charts. Yeah, so mutate has many options that it's really useful to explore. I think the keep, the before, and the after are very good additions in the last release of dplyr. So this one keep, I'm using it a lot because many times you're just creating new columns from columns that you want to discard. So now I save my changes. So now my object charts here in the global environment has 118 observation and 7 variables. And if I look it with view, now all the columns are complete. Yeah, thanks for putting there the link to the reference for mutate. It has many great options, so it's a very good idea. Okay, so we accomplished like the main objective of the web scraping, because now what we have here is one big data frame with all the information in the 6 tables that were on the Wikipedia page. So in the last 10 minutes, what I'm going to do is I'm going to clean a little bit this data frame. One of the problems with web scraping is that many times we not only get the information we want, but a lot of more things. For example, here we got all the links. These like square brackets and numbers is the way that Wikipedia put references. So it's not very clean here. Exactly, we have the footnotes. And we really don't want this kind of information here. For example, here we just want the year, not this information. Or here in period active, we don't want that. Or in total certified units or claim sales, we also have that kind of information. For example, here, or in genre, we also have that information. So we want to remove that. So that's where using regular expressions can be very useful, because it's the same pattern. We want to look for square brackets with a number inside, and we want to remove that. So what we're going to do is do some cleaning to our data. So this is the pattern that we want to look. So I find useful sometimes to create a string with the pattern we are looking. So So I'm going to create a string that, for example, said a word, and then 45, like an example from. So we want to check for this, find a regular expression that help us take this pattern away. So I'm going to create that string, and I'm going to use from the stringer package a function that's called str string extract. And I'm going to try to find this pattern. I'm going to start like checking for trying some different regular expressions to take this pattern away. I'm going to put it without the space. So in regular expression, we have a pattern to extract numbers. It's 2 backslashes and a D. So if I run that, it's going to give me back only the number 4, because \D only gives us one element. If you want one or more, you need to add a plus sign. So now it gives me 45. But we also need the square brackets. So I'm going to try with the first one. I'm going to put square brackets here. And if you see something very strange happen, because now it gives me something else, it only gives me number 4. The thing is that square brackets are used inside regular expressions, so they're a special character. So we need to escape them. So we need to use backslashes, 2 backslashes to tell R that we want a square bracket literally. So we don't want for R to interpret that the square bracket is a regular expression, but just the pattern that we want to use. So I'm going to escape the 2 square brackets. So now I'm getting the pattern I want. So because what we want to remove here is this pattern, so square brackets and number. And with this regular expression, we can get that part of the information in our columns. So we want to make this change not only in one column, but period active, release first year, and genre have this problem, the same problem. So this one has a square bracket with number, release first started 2, and genre 2. And there's a very interesting function from the deep layer package that you can use with other functions from that package, like mutate, for example, that's called across. And across will allow you to use a function in many columns at the same time. So that's what we're going to do. So first I'm going to try with, I'm going to take my object charts. I'm going to use mutate. And I'm going to use here the function that's called across. So I'm going to set R that across. First, I have to tell R what across which columns. So I want to apply this, I want to remove this from period active to genre. So these 3 columns, period active, release first started, and genre. So I'm saying across period active to genre. And then the function that I want to use. If you need to specify arguments to the function, in this case, I'm going to call the function using first tilde sign. So I'm going to use here string remove all. Usually here you said the name of the object you want to remove things from. In this case, I'm going to use .x because it's in the columns that we select before. And then we name the pattern that we want to remove. In this case, this is the pattern we want to remove. We're using the tilde sign in this case because you don't use it in across when you're calling the function without arguments. In this case, that we need to define arguments, we need to use it. So R can know that after calling the functions, there are going to be arguments called. I think if we have time, the next example I'm going to use, if we clean enough, I'm going to use the same function, but without arguments, so we won't need to use the tilde sign. So I run this function, and now in period active, release first started and genre, we don't have the brackets anymore with the numbers. So instead of doing the same process in one column and then the other and then the other, for example, using 3 times mutate, we can use a cross, saying all the columns that we want to apply a function, and then the function that we want to apply. So because it worked as we expected, I'm going to save my changes and rewrite my object. So now if I see the charts object, I can check it with view, for example. And now nor period active, release first started, or genre has the brackets inside. So there are many things. So using regular expressions can help you to clean the data in many ways. So it's very interesting to explore the different functions that you can use to clean it. There are things that we can clean in this data. For example, convert the year to numbers. So what we can do that is, for example, we can call them with the mutate function. So we can rewrite our chart objects, and we can mutate in charts. And what we want is that it's first release first started is the one that's, yeah. So we want that release first is first started, and we want that column to be as numeric. So now it's our column is numeric. So that's another change that we can make. Other things that we can fix, for example, is separating the claiming sales. Sorry. So claiming sales here has two numbers. In one we have like it's like there are two versions. Like the first one, like the official, and there are some other that cite other sources. So have a second number of claim sales. So this is not very useful as a column because maybe we want the numbers, so we can do things with numbers. For example, see which is the artist that the genre, for example, that has more claim sales. So this is the last example that we are going to use. And the rest of the code to cleaning this data frame, I'm going to write it in the same link, in the same file. So after the workshop, I'm going to add it. So if you want to see the complete example. So the last thing I'm going to do is separating claiming sales. So we have our charts data set, and I'm going to use the separate function. The separate function from tidyr allows you to separate a column in two. So the column that we want to separate is this, claim sales. So I'm going to separate claim sales. I have to set, the second argument is the names of the new columns that we want to have. So the first name is going to call claim sales. That's like the official name. And the other one is going to be called claim sales alternative. the third argument is which is the separator, what is separating currently the two pieces of information, and what is separating them is our same pattern here. And there's an argument that is usually useful to use. That's called what we want to do if there's like extra information. For example, we here are saying that we want to split this column in two. What happens if separate finds one line where it found the separating criteria 2 times, so it should split it in 3 columns instead of 2. If we use merge, it's going to put everything in the second column. I'm going to split this. Okay, so now we have the first column that had the first number, and the second one has nothing in case there were information there. In some cases, you only have like this pattern that we removed before, and then we have like the other number, like 500 millions. So what we're going to do next is that we're going to so suggestion for period active column, we can replace present by, yeah. The only problem with that is there are some cases. So from present, we can take, for example, present with this year, and then we can split. But that will work, for example, in cases that is very neat, that we have like first year and the last one. But we have this kind of cases of bands that were like active in different periods. So maybe we can, in that case, as Akil suggests, create more columns with like period active 1 or period active 2 and things like that. But we can use the separate function for that kind of thing too. So it's a very useful function. So we separate that. I'm going to remove now the square bracket with number in the second one because we still have that pattern there. So I'm going to mutate claimed sales alternative. I'm going to remove all in claimed sales alternative and the pattern that we've been using. So now it's clean here. And the last thing that we're going to do is that we're going to, there are 2 ways of doing this. We can remove the million, for example, with string removal. We can remove the million, space million, or we can use a function that's called parse number. I'm going to look it here, parse number. That it's very useful when you have this kind of pattern. Let me rerun the code so it's print more neatly in the console. So you can take only the number in a column if you use parse number. So it's going to only extract, for example, 600 instead of removing, for example, space million and there turning it into a numeric column. You can do that. So I'm going to use mutate. I'm going to use, in this case, the across function also. And because we want to make this change in this case, in these 2 columns, I'm going to, one way to select these 2 columns is to use this help function that's called starts with. So I want to select all the columns that starts with claimed. And then the function that I want to apply there is parse number. So what happened? In this case, I didn't give any argument to parse number, so I didn't have to use the tilde sign before. So I say mutate across every column that starts with claimed, the word claimed, apply on those columns the parse number function. So it's going to extract the numbers to only the numbers that are contained in that column. But now the thing is that we remove the million words, so we don't know like which is the name, which is the amount that this number is reflecting. So maybe we can add the million word to our column name. So we can do this. There are different ways to do this. Across also have a way to do it. So we can add here inside across. Yes. There's a dot names argument that you can say if you want to do something to the names of the columns that you are using. So if you, in this case, I want to keep the whole name of the column and I want to add something to the end. So I'm going to use the way of writing the code from the glue package, the syntax of the glue package. So I'm going to say keep the name of the column and then add at the end underscore millions. Oh, sorry, I think I mixed the. This I had to do it outside, I think. No. I don't know. I think I made something. I'm not sure in this case it's going to work, but okay. But we can add then, we can use the same idea of across and adding, changing the name of the column there. So if you see, yeah, we can use the glue function too. I think I'm a little bit past of the time. So if you see what we did here was that we changed with parse number. It's very useful because it removed all the text from the column and it turned it into a number. So now we can do something with this information. So I'm going to save here the charts, our data. So now it's all the changes are stored. And for example, if we want to answer some question, we can see, for example, which is the genre that has the highest total sales. So I'm going to use our chart subject. I'm going to now use the separate rows function because we have all the genres in one column. So we have, someone has only one, but for example, this one have like 4 different genres. So what we're going to do is to use the separate function, separate rows. So we're going to separate genre and the separation pattern is space / space. So if we run that code, now we have like 1 row per genre. So for example, the Beatles has 2 genres, rock and pop. So now we have for rock and for pop their own line. So this allows us, for example, to sum up the claim sales by genre. So I'm going to group by genre, and I'm going to summarize. I'm going to create a column that's called total sales. That's equal to some claim sales. And I'm going to arrange so that the highest are at the beginning. So now we can see that the genre that has more millions sales is pop, then rock, then rhythm and blues, country, hip hop, hard rock, etc. So what we did to finish, we had this page that has like 6 different tables, and all of them has information, but it's split in 6 tables. So what we did was join them in only one. And then as we saw, that's one part of web scraping, but the most difficult part after that is trying to clean the data, because in cases, for example, like Wikipedia, there are a lot of things to clean. So using regular expressions and with dplyr and all the functions that this package offers us can help us to clean everything and have more a more clean data. So as I said before, I'm going to the rest of the code to clean the table so that we have charts like with no more. For example, we still need to clean this column to total certified units that has a lot of information. For example, that's everything that it's inside one cell, because it has the total certified units from an artist, and then it splits for the sales of some countries. So this can be split, for example, in different columns. So this is something that we're not going to do now because we're out of time, but I'm going to put tomorrow the code down here in this, so you can check it with the same link of how you can clean those columns. Okay, so I think this is all for now, because now you're going to be seeing a package that's going to make everything more simple to you. The idea was showing first how everything is working behind, and now you're going to know about a package that's going to make your life more easier when doing web scraping. So I think that's all for now, and I hope to see you on the RStudio conference next week. So see you around. And thank you very much, Our Lady's Tunis, for the invitation.
Thank you, Riva. You really did a great job. I have learned a lot from you today. I hope that all our dear participants have learned a lot from you today too, using these wonderful R packages. And I hope that they are learning how to deal with the web scraping in R. So now we'll take a break time of 5 minutes, then we will come back, and we'll have between us Dr. Fodil, who will introduce to us his R package, Rager, who aims to make web scraping in R in an easier way. Thank you all.
due to the Our Ladies Global and Our Ladies Tunis initiative. The R community suffers from an underrepresentation of minority genders in every role and area of participation, whether as leaders, package developers, conference speakers, conference participants, educators, or users. As a diversity initiative, the mission of Our Ladies is to achieve proportionate representation by encouraging, inspiring, and empowering people of genders currently underrepresented in the R community and to facilitate individual and collective progress worldwide. Gabriela de Caros founded Our Ladies on October 1, 2012. Our Ladies Global was born and the grant was awarded in September 2016. Since then Our Ladies has grown to 170 chapters in 44 countries and 39,000 members. Our Ladies Tunis is part of Our Ladies Initiative and was created in May 2020 by women working as data scientists and biostatisticians and bioinformaticians. Our goal is to create an R community in Tunis and empower underrepresented genders in the R community. This is the core team of Our Ladies Tunis. Come and join our community on social media. This presentation was made with R Markdown. Thank you for watching this video and enjoy our workshop.
Hi again. So I think it's time to start with you, Dr. Mohammed. The floor is yours. Thank you.
So let me just share my screen for a second. Hopefully everyone is seeing my screen now.
Yes, it's okay.
Yeah, so thank you very much for the invitation. Thank you, Riva, for the awesome presentation. I really learned a lot. And hopefully she covers the most important parts of web scrubbing in R. So I'm just going to present very briefly a package that I developed recently called Roger that only simplifies a little bit the process of web scrubbing in R. I think we should cover most of my presentation in like 15 minutes, I hope, because I think the most important information has been already covered. So what is Roger? Roger is a package that is built on top of Harvest, but with the flavor of other packages that helps simplifying, as I said before, web scraping in R. So I didn't prepare some slides. Let's go for a quick demo. So here we are in the website of the RStudio Global Conference, which is scheduled to be held next week. I think so. So I'm just on the page of the speakers. So we can see here we have John Heston, Jo Young Siu, Karau, etc., who are all the speakers for the conference. And for example, what if I wanted to scrap the names of the presenters, right? So there is a function in Roger called scrap. So if I so let me just load the package, and the function is called scrap, right? And it takes only two main arguments or parameters: the link of the web page and the node. The node is really the HTML or CSS element that specifies the thing that we want to scrap. So I know between brackets it's scrapped with E, but back then when I was developing the package, I didn't know, so don't judge me. So here we have the link of the page, right? So let me create a variable called link in character strings. So let's go for a simple link. Let's say let's go for I'm on the second page. Let's go here on the main speaker page. So I just paste the link of the page. Then what I will use, as presented by earlier by Riva, is a gadget called Selector Gadget, which really helps targeting the specific elements. So I will just click here, and we'll let me just refresh it and select the element that I'm interested in. So if I click here, you can see that all the elements are highlighted in yellow. I can just copy this CSS class. So I copy it. So let me create also a variable called maybe element. And then I can just run the function scrap link and node, and it will object. I'm sorry, element here. So let me just link equal link, node equal elements. What is happening? I didn't run link, maybe. Okay, so now it will scrap the page, and you will have a vector of elements. You will have the names specified in the page. So it will begin from Aaron Jacobs to John Byrne Murdoch. So here, as you can see, so we have Aaron Jacobs here until John Byrne Murdoch. So it's scrapping right. But the question of ethics is really important, as mentioned earlier. So how can we just ask if we are allowed to scrap this web page from RStudio or not? So there is an argument here within the scrap function, within all the function of the Roger package. But I mean, let us see it. So we can just we have the ask robot, which is based on the robot.txt package, which is an argument that will ask the web page if we are allowed to scrap its content or not. So we can just put it, by default, it's set to false, but we can just put it and set it to true. And then it will ask the robot.txt if we are allowed or not. It will not stop the scraping, but it will have a message. As you can see here, it's printing, or the robot.txt doesn't prohibit scrapping this web page. So it asks the robot.txt and then it scraps. But if the web page that you want to scrap doesn't allow scrapping, you will have the message saying that it's not allowed, but you will either way scrap the web page. So you can just stop after that. All right, or you can just hit the stop button here in RStudio or Control-C whenever you are running the function. So I think it's quite simple. Now we have scrapped, and I think the first page. What if we wanted to scrap all the pages from this website? So we have here 3 pages, 1, 2, and 3. I think it's really easy. So we just need to have to find a pattern in the URL. So as you can see here, we have the 2, and if I change it, the 2 from 1, it will go to the first page, etc. So we have a pattern. We only need to replace these numbers by the. We just need to create 3 links with respective numbers to scrap the pages from the website. So let me just copy this part before the number. So I can just go here, scrapping multi pages, all right? So what I can do is I can very easily create a variable called, let me call it links, maybe, or link, let me call it link. So I just copy it. You can see that this URL has a different structure compared to the previous one. So I can just assign it to the variable called link. And then I can create another variable called links with s for plural, and just use the past 0 function. So I can just pass 0 and then the link variable and concatenate with 1, 2, and 3. So let me create a vector from 1 to 3, just as easy. And then I have now 3 URLs. So let me just check links. So as you can see here, we have like 3 URLs going from 1 to 3. Just a quick question: is the font size okay, or maybe someone is having difficulties seeing the screen?
Okay.
All right. Okay. So now I have 3 links. I just have to use the scrap function with the links and the same node, right? The same element. We also need the names of the presenters, and then if I run that, I will have all the person that will present during the conference. It's taking some time because my internet connection is not that fast, and I'm opening Zoom, which absorbs a lot of internet. So as you can see, I have, like, in this time, I have 57 people instead of like, I think 9 or 10 in the one web page. So we can check that. We have the first one, the first presenter, who is Aaron Jacob, and the last one is called ZG. So if we go to the last person here, we have a person called ZG, who is a machine learning developer based in Melbourne, Australia. So as you can see, it's quite simple. You don't have to write a for loop or something, or an apply function. So it's doing that behind the scene. So you just need to find the pattern for the URL that will repeat it, and just put the argument in the respective place. All right. So, I mean, that's fine. But what if we wanted to have a data frame like, oh, Yanina is here, awesome person. So what if we wanted to have a data frame like, for example, the name of the speaker and the description. So let's have a column for the name and a column for the description. So we can, of course, we can scrap the name and then scrap the description, and then use some fancy function from the applier to concatenate the columns into one data frame. But there is a shortcut in Roger that allows us to really scrap directly a data frame called tidy scrap. So what tidy scrap does is it scraps a data frame according to the elements that you provide. So we have, of course, we have our links. So let me call it. So we have tidy scrap. The first argument, of course, or the first parameter, sorry, is the link, the URL of the web page. So here we can just put our links. So the 3 links that we had earlier. Sorry, All right. And the second argument here, we don't have one node, but we have nodes. We have many nodes. So in this situation, each node will correspond to a specific column, right? So what is the node or the CSS class for the names? We have it already. It's media block link. This node. So we can copy it here, just easy. So we create a vector of many elements. And now, what is the CSS class that represents the description of the speakers? So we can use Selector Gadget also, very easy, quick. We copy it, and now we just paste it here. All right. So we have our two columns. We have our two nodes that will be translated into two columns. Then what we need to do is provide a names for the columns. It's a mandatory parameter, so we need to provide them. And each name, of course, will have to correspond to each node. So here, let me just provide a simple name. So speaker, and we have a description. All right. And yeah, we can just run it. Let me just make this bigger. And if we run it, we will have like a table with these two columns. Let's wait a little bit. Error connection, timeout reached. I think I have a problem with my internet connection, but just let me stop it and relaunch it. Yes, let me relaunch that. Let me assign it to a variable called df and relaunch it. I'm scrapping many pages, so it's taking a bit of time. I think it's the same. I have a problem with my internet. Let me just scrap one page, and just to show you how it works. But it works like the same, really the same way. Just need to have a nice internet connection. So let me just use the link variable here, which contains only one page, and just put it here. And let's scrap that. So now it's scraping, and I didn't assign a variable to it, but yeah, that's good. So we have our data frame. Let me just put it inside a variable so that we can use it later on. So I can just use df last value to catch the last value, which is a table. So I can just view the df, and we have this like this information, the speaker, the description, etc. So it's a quick shortcut to scraping tables which are not in HTML format. So sometimes in websites you have a table in HTML format, but sometimes you have just pieces of information that you want to combine with the table. That's a nice shortcut, I think, to this kind of operation. Of course, as you can see, the data frame has some HTML stuff here, like the /n, the /r, etc. That is a parameter in TidyScript called clean, which clean up this kind of stuff automatically for you. So we can just run here. Let me run clean equal true. By default, it's equal to false. And then if I run that, I won't have any more this kind of slashes. So I will have a clean table, like ready to be used or exploited, etc. So this is for the TidyScript function. I think I will just stop for a minute and just see if there is any question so far.
Yes, we have a question from Shamsuddin. I think you can see it. He's asking if do you have options for scraping in batches of new seconds to prevent blocking?
In batches of few seconds to prevent blocking. I mean, it's possible to do. I didn't implement something similar, but it's possible to do like there is a function called the retry from a package. I forgot the name, which really when used, it will allow us to like if we fail in scrapping something, it will retry until it's success. So yeah, it's possible to do that. It's not implemented like inside the Roger package, but yeah, it's a possibility. Another question, Roger is available on Cran? Yes, it's available on Cran. I released the last version like last week or a few days ago. Thank you. Okay, it's possible to implement retry. Yes, yes, Jacek just mentioned the retry stuff, and yeah, it's possible, of course. Can you scrape table also? Yes, there is a function for scraping HTML tables. And Riva, this is Bob article. Thank you, Riva, for sharing the article of Bob Redius. So yeah, let's move on to see some. By the way, I will just share the link for the repo of the package so that people can read the functions descriptions later. So I think most functions are covered in the README of the repo, and I hope it's quite clear. But I will share it anyway. Just give me a second. Text conversation. All right. So here it is. Now, what we can do is go to another example of a table. So let's grab an HTML table. Yes, capped with E. Sorry. And here I have a link of the complete list of Pokemons. I was a big fan of Pokemons when I was younger. I'm not anymore. The Pokemons are like getting like really ugly. I don't know why, but yeah, yeah. So as you can see, this is an HTML table that can be like scrapped entirely. So there is a function in Roger called HTML scrap, which only requires the link, the URL of the web page, so we can copy it and go to like the function is called HTML scrap, I think, or let me just check that. Table scrap, sorry. So we have table scrap function, and then we need the link of the URL, and it will scrap our table. Just easy. So now let me assign this to a variable so that we keep it and we see it clearly. Let me just use last value. All right, now if we see the table, we have data frame of like all the information that was on the website. So we have the name of the Pokemon, the type. Here the type is like composed of two types as here. So we have type grass, poison. So as Riva mentioned earlier, so yeah, we would have to make some cleaning, also some deep layer stuff cleaning, which is I think doable. We have the columns that were mentioned, total, HP, attack, defense, and we can just we can get some information. So we can see that Mewtwo is the most powerful Pokemon. Yeah, that was clear. So what if the question is what if we have multiple tables in one page, right? So we have a table, another table, etc. In one specific page. So there is a parameter within the table scrap function called choose. So for example, if you wanted to scrap the third table, you can just put 3 here. The first one, the 1. Of course, R is 1 indexed. Yeah, so I mean, sometimes it's a bit confusing. So the first stuff is 1, not 0, etc., etc. So that's the main parameter for choosing tables. And we have the fill parameter from Arvast, which allows you to deal with columns with inconsistent structure. And of course, you have the header parameters asking you if you want to have the first line as the header or not, and the ask robot stuff option to ask if we are allowed or not to scrap the web page. All right, so that was for table scrap. Now there is also a function that is used. I implemented it mainly for people that were working on text analysis, on political science, etc. So it's a function that's used to extract the titles from websites. So if you have, for example, this web page from the New York Times, and you want to scrap directly the titles, I mean, of course, it's possible and easy to do with rstats, but you will have to concatenate and then etc. So I mean, it's just few seconds of gain, but repeated many times, it would be beneficial. So what we need is the link of the page, and then what we can do. Let me just do that. Scrap the titles of the New York Times. All right. So we can do title scrap, I think it's called. We can provide the link. All right. So only by providing the link, we will have all the titles from the web page. Not all the titles. I don't know if people are a little bit familiar with HTML, but we will have the levels H1, H2, and H3. So we will have these three levels, which I think are the most important. But yeah, of course, it's always possible to filter later. So what we can do is run this function and see what happens from the New York Times. So let's wait a little bit. Yeah, so we have all the titles. We have advertisement, of course, listen to daily, the book review podcast, new warning of violence, security titans, etc. Inside Twitter decision to cut off Trump. I'm aware that some titles are a bit fuzzy and not really interesting. For example, advertisement titles. So we can get rid of them by specifying a filter. For example, let's say I'm interested in all the titles that speak about Trump. So I can just provide the contain parameter and just put Trump here.
Sorry
yes?
for interrupting you, Fodil. You have only 5 minutes more remaining. So just
I will just present this function and another one.
Okay,
Cool.
thank you.
That's cool. I will just speed up. And then I have the case sensitive parameter that just tells to just don't look for this word in case sensitive manner. Just give me Trump. And then I can just run it again, and it will just give me all the titles of the Trump. Trump-related titles in the New York Times. So let's wait a little bit. Let me just go for another. I don't know why it's so slow. Let me just stop it and rerun it. My Zoom is really eating all my bandwidth, but I think that's fine. I'm just going to present my last function, not last function of the package, because there are other functions that are just work similarly. You can just read about them. But my last function that I implemented is used to scrap the images from a web page. So I went to the OpenScience webpage to scrap these images that I will delete, of course. Some people working with R and with who really build interesting stuff. So if I want to scrap all the images from this page, I can just copy this. I can see that the function has been run, and you can see that only the the titles that contain Trump have been scrapped. So concerning there is a function called images scrap, right? So I provide the link, and then what I need to do is providing the path, not the path, the extension of the image, because there is the JPEG, there is PNG, etc. So I can just go for JPEG here. Let me just zoom out a little bit. I think I have a minute or so. So how do you know if the images contained in web page are JPEG extension or not? There is also a function called preview, like images preview, I think, which gives you all the links of the images within the website. So you can just run it, and you will have here all the links, and you can see which extensions you are interested in. If I run this images scrap function, it will just download all the images. So it's quite useful when like you need something. Of course, it will be a bit slow because you will have to it downloads image by image. All right, so it's a for loop, and for loops are in R like a bit slow. So, but it does the job. So you can see here as it goes one image by one image, and it keeps the name of the image. Yeah, you have like, let me just check the folder. Show in folder. Let me stop it. I think we have enough images. Of course, I will remove them. Let me just stop this. We don't have time for it. All right. So we can just show folder in new window, and we have all the images downloaded from specific page that we can just yeah. So I think I have covered the most of it. Thank you for having me, RStudio Tunis, and thank you for what you are doing for the community. It's interesting. I'm keeping my eyes on your workshops, and thank you everyone for being here. And yeah.
Thank you so much, Fodil, for this great presentation of your package. I hope that everyone will have the opportunity to use this great package. So thank you all for joining us today. Let me just, I want to just briefly let you know about our next two meetups in January. So if you can please stop sharing your screen, Fodil. So
yes, sure.
yes. So we'll have two meetups next Friday, which is part of our bio info series that we have launched last September. Okay. So it would be about an introduction to metagenomics. Please don't miss this opportunity. Besides, we will have Cosima between us, which will animate a workshop about NLP using supervised and unsupervised approaches. So my friend Haifa will put the links of these both meetups on the chat. Thank you all for joining us today. And stay tuned. We'll be sharing the workshop materials on our YouTube channel as always. And goodbye.
Bye.